All right.
Yeah, just
All right. So it's number 11, 5C. All right, so these are final grades in a course, and you're going to construct a table for the grades.
mhm.
And so the way that they listed out these 20 grades, it was at least they kind of put them in order. A's to B's to C's to D's to F. At least they're not mixed up. So at least makes them counting them easy enough. So you see a frequency table, and they've got a heading of grade, and you got A here, and then next column is entitled frequency. And that's an open field. You got to put that in. And then the next column is relative frequency. So remember, this is going to be the percentage. So you'll have this column. And again, you've got to fill in a field here. And then the last column is cumulative frequency. Okay, so what we're going to do is fill in these, and then it looks like you'll hit check answer once you input into those three fields. So the frequency for the A, you're going to count up the number of A's. So for the problem I'm looking at, there are 4 of them. Now again, relative frequency, that's going to be 4 out of, and it says there are 20 of them. And well, actually, it doesn't say how many there are. I thought I read 20 for some reason. So that could be wrong. I'm going to have to count 1, 2, 4, 5, 6, 7, 8, 9, 10, 11, 12. So actually, there are 24 for my problem, counting up all the grades. But this isn't what they want. They want it as a percentage. So you've got a blank box and then a percentage symbol. So here you're going to want to get your calculator. It says type an integer or decimal rounded to the nearest 10th. So that will tell you how to round these. All right, so I'm grabbing my calculator, and I'm simply going to go 4 divided by 20. And that's going to come out to 0.2. So now 0.2 as a percentage would be, and so this is the answer you'll actually want to put in, 20%. Okay.
Is it 4 divided by 20 or 4 divided by 24?
Oh, it's 20. I inputted 20, but it's 24. And I thought 20. I do apologize. I am tired tonight. It's been a long, well, ever since the weekend. I apologize. My mom's in the hospital, and she went in. We had to take her in Sunday. She's doing better. She'll probably be there through the week. And this is somebody, I think the last time she was in a hospital was when I was born. So that was a long time ago.
Oh, I'm so sorry.
Well, I
I
appreciate
hope
it.
she gets
Thank you.
better.
She is, yeah, she is definitely getting better, but it you know, it was, I'm just tired. So,
Yeah.
okay, so thank you, Casey. Let me read that. 4 divided by 24 is 0.16 repeating. So if it's 0.16 repeating, I would round up, and I'm going to round to the nearest 10th. That's going to make this 16.7%. Because you'll have 0.1 and then 6, 6, 6, 6, 6. So you would move the decimal place twice and then round up 16.7%. Now the cumulative frequency, you're going to add as you go. So the first entry will be 4 here because that's all I've got. And so I'm working this problem as we go. So I need to punch the numbers in. 4 and then 16.7. They provide you with the percentage symbol, and the cumulative again for this one will be 4. All right, so moving on. And then the next is B's. So I'll count up the number of B's. So for me, it's, and again, it at least makes it nice that they arrange this so that they're not all scrambled, in which case you'd have to rearrange them just to count them up. 1, 2, 3, 4, 5, 6, 7. So there's 7 B's. So you'd be looking at 7 out of 24. And so 7 divided by 24 is 0.291, and then 6 repeating. So if it's 0.2916, then as a percentage, that's going to be 29.2%. And then here for the cumulative frequency, this entry will be 11, because it's, again, what you're going to basically be doing is adding this next frequency. So 4 plus 7 is 11. And so I'll throw these numbers in here. 7, 29.2%, and then 11 on the cumulative frequency column. All right, we're good there. So on to the C's, and counting those up, I've got 1, 2, 3, 4, 5, 6, 7, 8. 8 C's. So this would be 8 out of 24. And then 8 divided by 24 is 0.3 repeating forever. So this would be 33.3%. And then your cumulative frequency at this point would be 11 plus 8, or 19. So 8, and then 33.3, and then 19. All right, D's, there appear to be 3. So your frequency would be 3. Then your relative frequency would be 3 out of 24. So 3 divided by 24 is 0.125, and then it terminates right there. So this would be 12.5%. And your cumulative frequency would be 19 plus 3, which would be 22. All right, and I'll throw these numbers in. 3, 12.5%, and 22. And then we have grades of F, and there are 2 of those. So 2 out of 24. And then 2 divided by 24 is going to give you 0.08, and then 3 repeating. So that would be, as a percentage, 8.3%. And then you would add 2 more, and there's your, so this number here should match up with the total numbers. And I just counted all the grades, and I counted 24. And so this last number here should match with what you, if you counted up all the data, which it does. So, so I got 2, and then 8.3%, and then 24 on the last entry of the cumulative frequency. Okay, so then it asks you for totals on the frequency. Again, it would be, I have to add up to be 24. Your percentages should add up to be 100%. And the cumulative frequency, again, that entry should match the last number here. So it asks you for totals, so it puts total. Again, this should have to be 24. This column here should add up to be 24 over 24, which is 1. And this should add up to be 100%. That's provided. It didn't ask you to input there. And then this right here should match up with this number. It should be 24. So basically you enter 24 in both those fields, and that's it. That's the problem.
Yeah.
Any questions on that?
I don't think so. That makes sense.
Okay. I'm just looking to see if there was any variation on 14. And the difference on 14 is that the categories, here, this was what we would call qualitative data. These aren't numbers per se, these are grades. But on 20 or on 14, it's you are going to arrange, and in this on 14, it's going to take you a little bit more time, where the data is numerical, so it's quantitative. And so you would on 14 have the same columns of frequency. You would have relative frequency, and you've got cumulative frequency. But here they have arranged into what we call bins, BINS. And they are what we call 6-point bins. So I'm going to turn the page. And the first bend is from 94 to 99.
Oh, sorry.
And these are exam scores. So I would put scores here. And then you've got frequency. I'm going to abbreviate this time. And then you've got relative frequency. And then you've got the cumulative
Take the picture.
frequency. All right, so, but what's going to make this a little bit more time consuming is the data doesn't arrange it in any kind of numerical order per se. You just have to look at the data values, and it looks like there are ones, counting them up, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So I'm counting up 20 test scores. You're going to have to go through those 20 scores and actually count out how many fall between 94 to 99. Now this is inclusive, so any score from 94 up to 99 you would throw into this bin. And again, it's called a 6-point bin. So if you went 94, 95, 96, 97, 98, and 99, 6.
Okay.
All right. So what I would do if it were me, I didn't really leave myself a lot of room up top, so I'll get down here to the bottom. I would actually write out the data. You have 91, you have 77, you have 93, you have 88, 67, 83, 94, 77, 72, 92, 96, 94, 91, 91, 89, 94, 96, 70. I have left some gaps there. Where was I at? 70. So there are 2 more data values, 84 and 72. All right, so then counting real quick, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. But I would write them out on a piece of paper, because what I'm going to do next is I want to first capture all the scores between 94 and 99. So if it is in that bin, I'll cross it out. And so I just go through and do that. And the first one I hit is here. So there's 1, there's 2, there's 3, there's 4, there's 5, and that appears to be it. So that would be the frequency. Then the relative frequency would be found by going 5 divided by 20. So 5 divided by 20 is 0.25, or that would then be 25%. Then the cumulative frequency, and this is where we add as we go along, so this would be 5. So I'm going to go ahead and throw these numbers in here. And then 25%, and then 5. And we're good. Okay. And then once you hit enter, they are kind enough to actually give you the next bin, and it's going to be 88 to 93. And again, that would give you, there's 6 data values total between 88 and 93 inclusive. So, and of course, you can also look at it this way. You could just go 94 minus 6. It's a 6-point bin, and 94 minus 6 is 88. And then notice 99 minus 6 is 93. So if you had to, write them up on your own. But they do give you those. So in proceeding with the problem, now you're going to count up all the scores between 88 and 93. And again, I would just do the same thing. I'd go through and cross them out, as that keeps you organized and helps you not miss any.
Okay, yeah, that helps a lot.
Okay. So any other questions?
I think that's it for me. Thank you.
You're welcome. Any other questions on 5C? All right, so
Missed class last week. Did you by chance post that video or?
I have not, and I realized that here as I sat down tonight, and I apologize that I didn't, but I do have it recorded. I have it uploaded to YouTube, and I will send that link as soon as we're finished up today.
Thank you, sir.
Yes, sir. Okay. So what I'm going to do is the 5D is talking about graphics and media. Of course, and part of this 5C was looking at graphical ways to organize data and present data. And we considered what we called histograms and line charts. We also looked at bar graphs and pie charts. In addition to looking at frequency tables and like we were doing right here. 5D goes a little bit more in depth with graphics. But I'm going to skip over that because I want to make sure we get to some other things before the end of the semester. So I want to move on to 6A today and talk about starting, how we can go further in terms of characterizing data. And so that will be our mission tonight. 6A, and we are looking at ways that we characterize data. And the first thing in terms of characterizing data is a word we use to talk about the distribution. So the distribution. The distribution. All right. Of a variable
What to say today?
Refers to the way its values, and a variable, remember, is just, it's a, we maybe assign a letter, usually an algebra X or Y, but it can take on any number. And so for our purposes here in statistics, we're going to say it refers to the way variable, its values, apostrophe, are spread out or spread over all the possible values. All right. And we can display a distribution with a table or graph. And visually see it. All right. Now, we won't actually look at all the ways that we talked about distribution tonight, but we're going to kind of get at least a handle on some of the ways we can talk about distribution. And in the first way that we want to characterize distribution is by finding what we'll call its center.
There might be.
Now, another word that gets used a lot here is average, but average actually really implies one thing, and it's not necessarily the center. But the three most common ways to find the center of a distribution we refer to as mean, and then something we call median,
Bless you.
and something we call mode, or what I call the 3 M's. And these are 3 different ways to find
Right.
what the center is of a particular distribution of a data set. So
Equals up to that.
now, the one that is most commonly we would associate average with is mean. Mean is the arithmetic
Saw dogs.
average of a data set. All right, so what do we mean by arithmetic average? Add up all the data values and divide by the number of data values. All right, so we're putting it another way. Mean equals sum of all values in the data set divided by the total number of data values. Which is how we find average. All right, so while we're on this, and you're not going to be tested on this. This is just a a little extra bonus in terms of, like, if you go on to take a statistics course, mean. So this is a sidebar of extra information. You will actually see mean represented with a couple different symbols in a statistics class. But the first way you'll see it is an X variable with a bar over it. And it's just red X bar. But that's going to mean mean. And generally speaking, we will take that to be the sample mean. But then you move in, we'll get in a statistics class where you'll talk about population mean, and we use a lowercase Greek symbol, sigma, which kind of looks like a sideways 6. Again, this is not something you're going to have to be tested on, just extra information. Now, how do we represent mathematically with mathematical symbols sum of all values? In mathematics, the capital letter sigma, which looks like that, though my sigmas that's actually, I shorthand them, and that's bad even for me. Kind of looks like this. All right, so this is my sigma. So if you take an advanced math course that requires you to write a lot of those sigmas, you end up getting kind of sloppy with them, not making them look like that. Now, I had friends that were still very meticulous. I was not. So, and I just always got in the habit of drawing them like this. But this is a sigma, Cunningham sigma. But it means summation. It means add. So add up all the data values X, and N always represents the number of things you have in a set. So this would be the way you would represent mean with a formula using mathematical symbols. But at the end of the day, mean is add up all the data values and divide by the number of data values. Okay. The median. And the problem, it's not that one is better than the other. A problem that you can encounter with mean is, say, like you are going to average up and find the mean of a set of test scores. And let's say 20 people took the test, and 19 of those students scored a 90 or higher. And one student didn't come to class and didn't study, and they scored 2 out of 100 on their test. They had a 2%, and everybody else was 90% or above. Well, what would happen is if you added up all those scores and divided by 20, your mean, the arithmetic average, would actually probably be in the low to mid 80s. And since 19 out of 20 students actually scored 90% or better, you'd have to think to yourself that 80-some% is not reflective of the center of the data set. And what's happening is that one score of 2% is dragging that average way down. And we refer to that 2% as an outlier. So it's officially called an outlier. And I'll write a definition of that term here in a little bit. So you have a choice of, maybe you exclude that data value if you want to use mean, but a way to find a center that is not susceptible to outliers like mean is to use what we call the median. The median is the middle value. In the sorted data set. All right, so now what does that mean? Sorted data set. I have arranged the data values from smallest to largest in a ascending fashion. So from left to right, they get bigger and bigger and bigger and bigger. But I've rearranged the data values from smallest to largest. And so if it's the middle value in a sorted data set from smallest to largest, then we're saying, now, I got to be careful though. And different books will define this differently. I go with, I like how my definition of handling the situation is, how the book does it is exactly how I do it. If you have a even number of data values, then there's not going to be one middle number. You're actually going to have two middle numbers. If you have an odd data set, like say 9 data values, then you would have 4 and then 4 on the upper end, and you would have 1, that would be 8. You would have 1 right in the middle. So what you do if you have a even number of data values is you find the 2 middle values and find its mean. That is, add the 2 up and divide by 2. The book actually defines it a little bit different. They say halfway between the 2 middle values, which is true, but that is the mean of the 2 middle values. So what we'll say is in our definition, or the mean of the 2 middle values. I'll break that word a little better. The 2 middle values if the number of values the 2 middle values. Ooh, what did I do? Values is even. All right. So, and again, so if you go back to the example of 20 test scores and 19 were 90% to 100%, and 1 was 2%, and you looked at the median, it would be much more reflective of the center of that distribution. All right, so mode is simply the data value that occurs the most. So, or is the most common data value. Okay, in a distribution. Okay. Now, you can have more than one mode. I mean, you could have a set of data, 30 data values and have 3 different modes. You could have 3 different values occurring the same number of times and would be the most. Let's say you've got, out of that 30, you had 4 5s and 4 8s and 4 12s in that group of 30 numbers. And so, and if there's no mode, if there's no data value occurs more than once, you just say the distribution has no mode. All right. So, questions thus far?
I think I'm okay, Mr. Cunningham.
All right.
I'm good.
All right. So let's look at a example here. Let's say I'm selling a type of energy candy bar, and here are we've got 8 different grocery stores. So I'm going to have 8 prices that they sell this energy bar for. So one sells it for $1.09, one sells it for $1.29, one sells it for $1.29. The fourth one sells it for $1.35. Another one sells it for $1.39. One sells it for $1.49. Next one sells it for $1.59.
Yeah, so active.
And the last one sells it for $1.70, $1.79. So if I were to find the mean, I have to add up all these scores, which this book does not do. So I'm going to do that real quick. 1.09 plus 1.29 plus 1.29 plus 1.35 plus 1.39 plus 1.49. And let me put a plus in there. Plus 1.59 plus 1.79. All right, assuming my arithmetic was correct in adding up all these scores, dollar amounts, I get 11.28.
That's what I got.
All right. And then there are eight of them. So divide by 8, and that gives me $1.41. And so that would in fact be the mean. All right. Now the median, and I have already, if it's not done, then when you're doing this by hand, then you have to come in and arrange these again and sort them from the least value to the largest value in ascending order. Now, since there were 8 of them, what I would do is I would find that there are 2 middle values. You'll have 3 here and 3 here, and you got these 2. So the median, again, I just say it's the mean of the middle 2. So we add these 2 up and divide by 2 in this case. But it's an odd data say there will be one data value right smack in the middle. All right, now looks like halfway between should be $1.37. But I'm going to go ahead and add them up just for the heck of it. 1.35 plus 1.39 is 2.74 divided by 2 is what we already knew should be 1.37, $1.37. And then the mode in this case looks to be $1.29. It's I don't see any others that occur more than once except for these 2. And so that occurs twice, so that should be your mode. Okay. All right, mean, median, and mode. Now, the TI-30 XS does not. It does do some stuff, but not like the TI-84. TI-84, and I'm not going to show you tonight. I'll show you next time. Once we maybe talk a little bit about standard deviation and quartiles and whatnot. You can input all the data in and just do a command of make it actually find a bunch of statistical stuff, just like boom, lightning fast. It will find the mean, median. It doesn't tell you mode. It will give you the mean and median, plus a lot of other statistical information. So if you take a statistics class, you're going to want to have a TI-84 for sure. So, and then of course there's all kinds of computer software that will do this stuff. And either of you two ever worked with Excel?
Yeah, I have a little bit.
Okay. You can if you use Excel, then you know you can program uh, it to do calculations with data. And one of the things you can do is, have it calculate the mean of a data set or the median of a data set. It's a matter of being able to write. It's kind of like basic computer language. So I actually, back in the coaching days of baseball, used to use Excel to compute batting averages and slugging average and on base percentage and different things, statistical things you want for baseball. So, all right.
Yeah, oops, no.
Okay.
Not sure. Off the ball.
Okay. So turn the page. And
This would be deeper in.
I want to start looking at kind of distributions graphically in terms of drawing out a distribution and looking at it visually. And when that back to the term mode, which we know again most frequently occurring data value, and there can be more than one mode. So kind of tackling what a
Yeah, it'd be another,
sorry about that. Hey, give me just 1 second. Hey, I'm in class. Can I call you back? Okay. So got an example, some real world examples. Okay. So got 4 of them, and we're going to be able to look at what a distribution graphically may look like for these 4, and also consider modes. Most frequently occurring data values would look like in regards to drawing out this distribution. So the 4 examples we're going to look at, the first one is considering the heights of 1,000 randomly selected adult women. So just so we go out randomly. We've certainly talked about, getting a random sample and different ways to do that. Simple random sampling and stratified and so on and so forth. And then the second one will be hours watching football and TV in January for 1,000 randomly selected adult Americans. The third one will be weekly sales throughout the year at a retail clothing store for kids. And the last one will be the number of people with particular last digits 0 through 9 in their social security numbers. Okay.
This is what I was going to test.
All right, so let's do the first one, heights of women. And what this, looking at the distribution would look like.
Yeah.
So I would draw a graph. So I'm going to have a horizontal axis and a vertical
You
axis.
guys go.
These are going to be the actual heights. And this is going to represent remember we randomly selected 1,000. So number, all right. Now, the distribution of physical characteristics of human beings in general, in this case, women specifically, that is, if I measure height, if I measure weight, so on and so forth, was always comes out to be what we call unimodal, which means there's one mode, unimodal, one mode. And not only that, and we're going to talk a little bit more about this, is what we call a normal distribution. Or sometimes you may have heard the phrase bell-shaped curve. So that is, you'll have some women who are on the short end down here, and it kind of comes up, goes back down like this, and then you got a few women here who are really, really tall, and most are right in here. So, but there would just be one mode, and when we talk about a mode looking at the graph, it means the peak. All right. So, and again, this is also referred to as normal curve. So that was the first one, the height of 1,000 random selected women. So here's what a distribution would look like for those football viewing, taking 1,000 random folks and looking at their football viewing TV habits. So horizontal axis will be how much time do we spend watching the TV? And then again, this was 1,000 randomly selected people. So the number, in this case, people. Selected people. Okay. Now, most likely in this case, it's going to be what we call bimodal. There's going to be two peaks. One mode represents the most common watching time of big fans, and the other is going to be of what we would call more casual fans. And so it kind of looks like this. As I come up, you're going to have a little peak there, come up and peak again, and come back down. Sorry for my artwork. But right here, this would be your mode for casual fans. And remember, this is TV time, so this would be a little less, right? Which would probably be like where I would fall. Especially pro football, not what you call a huge diehard fan. So I will watch some. Like last night, had the Steelers and the Bears playing last night, and I had it on, kind of dozed off a little bit, and was tired, and I don't know, I didn't even make it to halftime. So casual fan, but then you got your diehard fans, and but this would be here representing, because they're definitely going to watch more. So mode for, we'll call them big fans. So I have, I got friends that just, they've got the NFL network and they never miss any games. So, all right. So then the next one we were going to consider was weekly sales throughout the year at a retail clothing store. So again, horizontal axis and a vertical axis. And it's going to be number of people here buying clothes at the retail store. And this is going to be time of year. So in this case, the months, I would just go January, February, March, April, May, June, and all the way through what, December. Now, here, this is gonna, we don't really beyond bimodal, we don't say trimodal or quadmodal, we just say it's got a lot of modes. But if you think about clothing time, you got your spring sales, so you probably have a peak there. And then you got back to school, so that'd be another peak. And then you got the holidays, so there's another peak. And notice, the number here of people, these don't all have to be on the same. It's just you've got a group clustered within, this might be a little smaller number than this one. But again, this, spring sales, back to school sales, and then holidays. And then finally, last one was Social Security numbers. And so again, vertical axis was number of people.
Yeah.
And this is going to be last digit of your Social Security number. And so the possible numbers here are 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. That's your possible digits. Remember, this one was months, January, February, March, up through December. Okay. Now,
It worked.
so with Social Security numbers, because we all have a unique number, and we're looking at the last digit here, there's a 10% chance that is 10% of all Social Security numbers end with a 0, and 10% Social Security numbers end with a 1, and 10% 2, and so on and so forth. So what you have here is no mode. It's just going to be a flat line going across like that. Didn't want that quite to go beyond 9. I'll try it again here. But no mode. So here you have many modes. Here no mode. Here was bimodal, and here was what we call unimode or one mode. Okay. Questions on that?
No, that makes sense to me.
Okay. So when we look at graphical distributions like this, ways we can analyze them with what we call symmetry or skewness. So now about symmetry. So if we had that normal curve, that bell-shaped curve, so kind of did this. Oh, it's terrible. What we're going to envision is that there is what we call a line of symmetry. And that's what this is, line of symmetry. That cuts this in half. So my artistic rendition here does not show it as well as I would like, but this is exactly the same as this. It's the mirror image across the lines, and you could have it still, have that is, the distribution is symmetrical. There is a line of symmetry, vertical line that will cut it in half, even if there's more than 2 modes. If there was multiple modes, as long as you can cut it in half. So I'm going to try to best I can, but there would be a line of symmetry that would cut this one in half. Okay, now, but not all distributions are symmetric.
It's not a-
And sometimes we can identify what we call skewness. So two types that we identify. One may look like this. There's one mode, but it's not normal shape.
What's the-
And
Yeah, take this.
oh boy, I wish I had artistic ability. I'll try again here.
I'm gonna take the last one.
Third time's a charm, or I'm gonna strike out.
Definitely try to hunt it.
All right,
Wait, no.
this is about as good as I'm gonna do.
Like,
And then flip side of that would look like this. All right. So this is referred to be left skewed. And this is referred to be right skewed. Now, if you are left skewed, all right, and I never actually officially defined the word outlier, and I'll get back to that in a minute, but your outliers would lie, right, low values, and they lie way over on the left side. For right skewed, your outliers would be high values over here on this side. So outliers on low values and outliers here are on the right side. It's right skewed, but are high values. But if it is left skewed, when you calculated your mean and median and your mode, it would always go this way. Your mean would be here. Your median would be larger than your mode, or excuse me, than your mean, and the mode would be larger than either of those two. If you're right skewed, it's just going to be the opposite. The mode is going to be your smallest value. Your median would come next. And then the largest of those center values would be the mean. And incidentally, another phrase we use when we talk about center values are measures of central tendency. So now now, as far as the definition for outlier, I mean, I'm not sure I need to write this down, but it is a data value that is much higher, much lower than almost all the other values.
Yeah.
And we have already identified it can change the mean of a data set, but generally does not affect mean, median, or mode. Then one last idea for this section is what we call variation within the distribution. And variation describes how widely data values are spread out from the center of a data set. So in other words, wherever our middle is, then we want to look and see, are the data values spread way out from the center, or are they all compacted around the center? And there are, and we'll look at next time, ways we measure this variation. So based on mean, it's what we call standard deviation. If we are talking about median, then we'll use what we call quartiles, usually. Though you can also talk about deciles or percentiles. So now, how does that look on a graph? And all these are going to be symmetric. But if you have low variation, you're going to have something that basically looks like that, because all the data values are compacted around that center. Then moderate variation.
Yeah, we don't know what it is. Or we just guess.
Draw that far out. Moderate variation, you just start spreading it out a little bit more from that center. And then if you have high variation, then visually that's going to look more like this. Again, wanting these to all be symmetric. So that is it.